Welcome to Photon IIT Academy. In the previous session, we have discussed about the various fundamental quantities. And also, I have given one exercise. Let me complete the solutions of those exercise. Later, we can go for the other quantities. Here in the previous session, I have given dimension formula for momentum. Momentum is expressed as mass into velocity. Mass into velocity. Here, for the mass, expression is m, dimensional expression is m, and velocity is, previously we know that L e to the power of -1. Hence, the dimension formula is ml t minus 1. Is it clear? Let me go for the next one. That is, second, we have taken up the impulse. Impulse is defined as force into time. Force into time. The previous session we have seen the force dimension formula is mass into acceleration, ml t to the power of -2 into time t. Time is t. So here on simplification, m, l, and t minus 2 and plus 1 becomes t minus 1. So impulse dimension formula is ml t minus 1. So let me take up the third one also. Third is, we have taken up the pressure. So this pressure is defined as normal force by the area. So as you know that force dimension formula is mass into acceleration, ml e to the power of -2. Area, length into breadth, that is L into L, L square. So here, one of the L1 power will go out. So on simplification, it becomes M, and L, if it comes up, L to the power of -1, T minus 2. That was the dimensional expression for the pressure. This is the dimensional expression. ml -1, T minus 2. These were the previous exercise we have seen. Let us go into this session. In this session, let me take up some more dimensional formulae. I am taking up power. What is power? Power is defined as work done in the unit time, that is the work by the time. What is work? Work is also an expression for the energy. So in the previous class, we have seen work is nothing but force into displacement. So hence, the force into displacement, that is the force displacement. Force dimension formula is mlt minus 2, and the displacement is L. Hence, ml square t minus 2 is the dimension formula of the work divided by time is t. Hence, power dimension formula comes to be ml square. If this t goes up, ml square t minus 3. ml square t minus 3. If I take another quantity, that is the surface tension. Surface tension. Let me define the surface tension. This surface tension is expressed as the force per unit length. Force per unit length. That is here, force per unit length. What is the dimension formula of the force? M, mass into acceleration, ml t minus 2 to the power of minus. Length is L. So L and L goes out. It becomes M t minus 2. This is the dimension formula of the surface tension. So it is very simple that if you want the dimension formula of the one quantity, if you remember previous quantities, you can easily substitute and you can easily get the other quantity. Let me take up the another one, pressure gradient. Pressure gradient. Gradient. This pressure gradient is simply defined as change in the pressure within certain distance or unit length, dp by dx. Simply, we can define it as pressure by the length. Pressure by the length. Observe, in the previous we have seen about the about the pressure dimension formula. What is pressure? Force by area. So if I take up, pressure is force by area. Force by area. This is pressure. And length is L. Force by area. If I take up force by area, force is ml t minus 2. Area is L square. If it comes up, ml t minus 2. This is the force by area L square. This is the entire thing divided by length L. Length. On simplification, the pressure gradient dimension formula becomes m L minus 2 T minus 2. because this one L, another L will get cancelled. So L square, it comes up L to the power of minus 2, T minus 2. This is the dimensional part. Oh, you have understood these things clear. Yeah, if I take up the previous units by making use of dimension formulae, we can also express those quantities in terms of the units. Let us see the units expression using the dimensional formula. Previous, we have seen the various unit expression. That is, here I take up. First one we have seen is velocity. Velocity. And velocity, we are defining it as displacement by time. What is dimension formula? LT minus 1. Let me express this velocity in terms of the units, velocity units I want to convert. L is length. Length unit is what? Meter. And T is for time. Time unit is what? Fundamental unit? Second. So, second to the power of minus. That means this is expressed as meter per second. Velocity unit is meter per second. Similarly, if I take up the second unit expression, previously we have seen the force. Force is mass into acceleration. So its dimension formula we have seen is mLt minus 2. Now let me express force in the units. M stands. What are the units of mass? Kg. What is the unit of the length? Meter. Hyphen. This is hyphen expression. And what is the unit of time? T. Second. Minus 2. Power minus 2. If I express simply kg meter per second square. This is the unit of the force, unit of the force. This 1 kg, if I put up that on a body, this is a body, let us say it is resting on surface. If I put up 1 kg body, and if this 1 kg body is moving 1 meter distance, this is the 1 meter distance, and body is 1 kg. 1 kg body, if it is moving 1 meter distance, the necessary required force applied is known as 1 Newton. 1 Newton. So, hence, this entire expression is known as 1 Newton. Capital. Yeah. That is what is meant by force. Here afterwards, this thing can be written as 1 Newton. Clear? Yes. Let me take up the another quantity. Another quantity I take up, previously expressed quantity. That is work or energy. Work or energy. What is the dimension formula? Force, that is the expression is force into the displacement. Force into displacement is the expression. Force is ml t minus 2, and displacement is L. Its dimension formula is ml square t minus 2. Let me put up this, the expression in terms of the units. I want to express in terms of the units. See, mass expression is kg and length is meters square, and this is second minus 2. So this becomes kg meter square per second square. And observe this. If I express in the previous quantities this force and displacement as it is, what is the force? Is Newton, 1 Newton, into displacement is what? Meter. So 1 Newton meter, this corresponds to the 1 kg meter square per second. Here afterwards, this expression can be put up as 1 Newton meter. And remember, this 1 Newton meter can also be expressed as 1 joule. 1 joule. Okay, work unit is expressed as 1 joule in the SI system, and in the CGS system, it is ergs. Okay, so this session we have seen the dimension formulae of the sum of the quantities. Similarly, how to convert the dimension formulae in the units expression also. Let me give some exercise to you, and this exercise here I put up. This is the exercise for you. Express the following things in terms of units. Here I am putting power. Number 2, pressure. Pressure. Number 3, previously we have seen pressure gradient. Pressure gradient. Pressure gradient. Number 4, surface tension. All these things to try to express in terms of units. I need the units expression for this. Make use of the dimension formula and find out the units for this. This is the exercise. Hope you liked the session. Let us continue in the next session. The next section I will explain is exercise problems as well as some more things. Thank you.